through a process known as polymerization.
I see.
Yeah, it means that your plastic material will have a lot of things or a lot of similarities with conventional fuel. Now, that being the case, so it means that if you have any plastic material and then that plastic material comes to its end of life, and by its end of life, maybe I have bottled water. So I put water in the bottled water. Its function is to contain the bottled water until the bottled water is consumed, and until the water in it is
It's
consumed,
consumed, yeah.
and then it's discarded.
Yeah.
So you ask yourself, once the water is discarded, does it mean that it has become useless? The answer is no. Which is why this is a change in connotation from the word waste to end of life. It will tell you that that plastic material has served its function for containing water. Then after that, you could have other uses for
So you can give it new life.
new life, new life, new life. So your plastic material will contain a lot of similarities with your conventional fuel. If you talk about the energy content, so the inherent chemical energy contained in the plastic is similar to those of diesel, petrol, and kerosene.
Right.
A typical example is what we call the calorific value. The calorific value of any of the plastics, sachet, shopping bags, and then the like, if you take a look at them, they are just about the same as those of diesel, kerosene, and petrol.
Wow.
So they are very useful. So because they were produced from crude oil, or petroleum products, let me put it that way, through a process of polymerization, we can work on the plastic materials and then think of reversing that
Reverting it
process
back to
to
the petroleum products.
the products that we produce
That's
from.
that's
That
fascinating.
is that concept of waste technology as applied to plastic waste material.
Wow. And I would want us to come to this whole process and how it is done. But how significant is this plastic waste problem in Ghana, and what kind of impact could it have on this kind of project that we're embarking on? What kind of impact could it have on reducing the plastic waste problem?
Thank you very much. Before I come to Ghana, globally, several millions, if not billions, of tons of plastic waste is generated. A lot of them will end up in landfill sites, or they'll be discarded indiscriminately. So it means that all these plastics will find their way into drains, gutters, a majority of them will end up in the oceans. Now, data from the World Economic Forum indicates that in the case of Ghana, we generate approximately 840,000 tons of plastic waste annually. Out of this, less than 10% is recycled. So it is a huge, 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 huge problem in Ghana. And those of us living in Accra, you will notice that anytime it rains for about 3 hours,
just a few hours,
the whole city
we
will
get
be flooded.
exposed. And
That is as a result of choked drains, gutters, and so on and so forth. And that is why it is a huge problem that should engage the attention of every Ghanaian.
Right.
Every Ghanaian.
Right. So, could you walk us through the technological process, used to convert this plastic waste into liquid fuels and its derivative? You've said there's a certain process called what?
Polymerization.
Polymerization. This polymerization. What is it? Is it? Are you converting? Maybe if it's a polythene bag, are you testing to see, okay, this was done through maybe petrol or through diesel, and you're converting it back to? How does it all work? Help us understand.
Yeah, so the polymerization process is actually so when you take the plastic materials, or normally what we call we use the term MERs. So we have a MER is actually a combination of carbon, hydrogen, and other compounds. And then we have what is known as a monomer. Monomer means one unit of the MER.
Okay.
And then we have a polymer, which is several units of the MER.
Okay.
Now, when you are producing plastics material, what they do is that they convert the monomers into polymers. and that is the process of polymerization. So we are saying that to produce the fuel from the polymers, then we need to work on the polymers, convert them from the polymers to the monomers. Now, this you can do by working on the plastic material through several processes. Now, a very good example of that one is what we call pyrolysis.
Pyrolysis.
So this is the technology that we have adopted.
Right.
But we use what is known as a catalytic pyrolysis. In other words, you work on the pyrolysis process in the process of catalyst so that you can, by varying the catalyst, you can produce various forms. For example, if I want to produce kerosene, diesel, petrol, or aviation fuel, I will know the type and amount of catalyst that I need to utilize. The good thing is that in our process, everything is produced by us.
Everything is done.
We don't.
It's done here locally.
We don't want to import anything. We produce our own catalyst.
Everything.
Everything. So that once you have the plastic waste, we have our reactors that we have designed and then constructed. The catalyst for the past 10 years, we started in 2014. We've tried various forms of catalyst, and we produce them from several materials in the country. We don't want to import anything. If you go to other countries like China and then the catalyst will be one of the most difficult aspects of the whole thing because they are expensive.
Yeah.
That is what we want to cut down on that cost factor.
But do everything here.
Here in Ghana.
That's brilliant stuff. So, what are there specific kinds of plastics that you can convert into this fuel, or all kinds of plastic? I mean, you mentioned plastic bottles. So, do we have like polythene bags, like empty sachet water wrappers, or what kind of plastics?
Technically, every plastics material can be used.
Technically, every plastic material. Like even some of the ones we have here on the desk today.
Technically, every plastic material, once it contains carbon and hydrogen,
right,
you can use it to generate liquid fuel. To maybe illustrate this, during the COVID era, 2020, 2021, and then you remember our nose mask?
Yes.
Yes. In our group, we found out that we had a lot of waste masks. That got to a point when you're discarding them, people will want to run away from any.
Yeah. Because they fear it might have been infected with COVID.
So to illustrate the fact that every plastic material can be used to generate the fuel, our group, we got members and then we gathered a lot of
nose masks.
The nose masks. And we decided that to test whether you could use it to generate liquid fuel.
And what happened?
We were able to produce.
You're able to do it.
Liquid fuel.
So what kind of liquid fuel is produced?
Yeah. You can produce any liquid fuel.
Any liquid fuel?
Yeah.
Petrol.
From petrol, diesel, kerosene, aviation or jet fuel, and then other non-condensable gases, which are also used as fuel.
Are there specific kinds of plastics which will give you petrol, and specific ones which will give you diesel, or all of it is generic and there's a particular process to make it diesel or to make it petrol?
It all boils down to the type of catalyst that you use,
right,
and the amount,
right.
So for now, I have decided not to produce any petrol for obvious reasons, because storage of petrol could become a problem until I get to a point where I set up something big, then I can produce the petrol. So for now, diesel and then kerosene.
So if there was something big, actually, you could actually be producing petrol from these plastics.
Yes.
And we could be using them in our cars.
Yes.
Or diesel.
Yes.
And we could be using them in our cars.
Oh, yes.
Yes. I mean, this is brilliant stuff, and I mean, if we could really focus, I'm thinking, this is just me thinking out loud, of properly investing in this kind of technology and doing it on a large scale. It could go a long way, to really help us even in that regard.
Yes.
Because we're talking of cost of fuel and all of that. It could significantly, if we can change waste into, it could help us. So I've seen that you've got some of the samples here. So what liquid fuel is this?
This is what we call the diesel range of liquid fuel.
So all of this is diesel.
So if you say diesel range, then we are actually referring to diesel itself, kerosene, and then aviation fuel.
So this is diesel. Some of
Diesel.
it is diesel.
Some of it is diesel.
Some of it is aviation fuel.
Aviation fuel. Some kerosene.
Some of it too is kerosene.
Yeah.
How are you able to tell? Is it the darker ones are diesel?
Not exactly.
Or
We, I've placed some numbers.
Numbers on it. Okay, so
it
you're able
depends.
to tell.
When we produce, we do a bit of analysis on them.
Right.
And then you technically, if you take diesel and kerosene, there's not much difference.
Not too much of a difference.
Sometimes the density, you may find out that maybe diesel is slightly denser than that of kerosene, and then aviation fuel. So they all mean the same thing. It's only the density and what we call the flash point.
Right.
That means different.
So I could put this in my diesel car.
Yes.
And it will run.
Yes.
Wow.
Yes.
Wow. That is brilliant stuff. And of course, if you're watching on our Facebook live stream, you see, the samples here. So the environmental benefits are obvious, but
Yes.
economically, like I've been thinking out loud here, what does Ghana stand to gain with such a project? And what are the potential cost-saving revenue streams?
Yeah, that's a very good question. Now let's take the various metropolitan, municipal, district assemblies and then like. Now this technology, you see that if I go to AMA, they have various ranges of waste. They have big trucks that will go around trying to find where to dump these waste materials and the like.
Yeah.
Now, if we have this technology and then the waste that they are producing on site,
Yeah.
or the waste that they've been able to gather in their metropolis, they can turn.
All the plastic waste.
Yeah. You can, the good thing about this is that you can mix this plastic waste with other materials, biomass and then the like, and then you can still generate.
You can still
fuel.
get it.
Yes. It all depends on, the know-how. You go there and then, in the plastic that I see, I can tell you that I can use this for that, this for that. So if they were to get to the point where they can generate their own fuel from their plastic waste along with other waste materials, that would be a serious cost cutting system for them. That's number one. Because remember, if you don't utilize them, you still need to pay money to find a suitable location
for
to
them.
deposit your waste. Yeah. So I see this as a way of they generating their own fuel that they can use to power their own trucks, and then to cut down on cost. Now, the other thing is also about job creation along the value chain.
Right.
Take the small girl or small boy on the streets of Accra selling sachet water. Now, if he or she is aware that when somebody buys water, so the product, normally sachet water, people are so thirsty, they buy it, drink it, and then they discard the plastic waste. If the vendor is aware that whatever the customer is throwing away can help me generate extra income, then they can also make extra money while they sell their sachet water. This will also help in cleaning up the environment. Knowing very well that plastic waste that are discarded indiscriminately will no longer be on the street because you have people who know
are
that
coming for them.
Yeah.
And then we can convert it into fuel.
Yes.
So it becomes
then
a valuable resource.
Yes, please. The one most important thing, currently, I think we are all crying about the cost of electricity. Electricity is expensive in Ghana for the excellent reason that the generation, previously we used to have the Akosombo Dam, and everything was hydrothermal. Currently, as we speak, 66% of the electricity generation in Ghana is through thermal
energy.
Thermal energy.
Yeah.
Now you may be wondering, how is this thermal energy generated? Simple. The power producers, ZRA, Bui, and the other independent power producers, all they do is that they buy diesel, natural gas, and all those things, and then they burn it.
And it powers the turbines to
fuel
to
is
generate the
expensive.
electricity. Yeah.
We are all crying about the cost of fuel.
Yes.
So if we can generate at least the diesel that they buy, part of it, if you can generate it from plastic waste,
It reduces the cost.
it can reduce significantly the cost
Yeah.
of electricity in Ghana.
So the long term, what are the long term goals of this waste to energy project? Let's say
we
in the next 5 to 10 years.
we want to already. There is also this issue. I was going to talk about this issue of premixed fuel,
Right.
which has been a thorny issue from government to government.
Mm-hmm.
Yeah, if I can generate my petrol from my plastic waste,
Yeah.
obviously I can generate my premix
premix
fuel,
fuel.
which I can make it available to these farmers, the fishermen who need them directly to go about their business. We are also in touch with mining communities. Corn millers, machines that these mining communities will use in grinding their ore. I'm talking about the legal, small scale people, not the illegal
Not the
ones.
illegal ones,
Yeah.
yeah.
This diesel, already we are trying some at home. Can just place it in the chamfer machine. It powers, crushes all the rocks, then cut down on energy so that they can also make some profit
Right.
and then employ more people.
Right. So, Mr. Brenfi, as a business development manager, what are your goals, for a project like this?
Okay, so thank you very much once again. From the business perspective, one key challenge with research institutions in Ghana mostly is, for example, beautiful ideas like this.
Yes.
Without an engagement with the media house or any other platform to create awareness, it only sits in the books. And business partners, industry who need to take up these kind of innovations will be starving for solutions. So for me, from the business perspective, my very aim is to create the awareness for beautiful innovations like this.
Right.
And that's one of the reasons why we are here. And then also, in the medium to long term, get people to invest. This is a very good candidate for scalability. If you want to scale this up, if you want to market it, because the technology is there, we have even produced samples.
Yes.
So with good investment, this can easily be scaled up, as he mentioned, from the MMDAs, and then they can generate their own power and energy sources. So my goal is really to create the awareness and then seek for opportunity for funding investment to scale this beautiful innovation up.
I want to believe you've already started doing something in that regard. So, what are some of the the people you are working with on this?
I think Prof can. He's been in touch with some agencies.
Yes. So, Prof, let me ask what kind of regulatory and policy support is needed to ensure the success and sustainability of a project, like this?
One thing that could help this technology in Ghana, I'm talked about the current exorbitant price of electricity, knowing very well that the 66% component is generated by just burning diesel, kerosene, petrol to generate this portion of the energy that we feed into the national grid. One policy that government can come up with to assist in order to make life comfortable for all of us is maybe to come out with a policy that could say that we cannot continue to buy just diesel, kerosene, and all those things from the conventional sources, since they are very expensive.
Yeah.
So let there be a policy where the diesel that we burn to generate the thermal component, we can produce this from waste plastics. In so doing, it will be like killing not 2 birds but several birds with one stone.
Sure.
You clean up the environment, you create job. That is a very important component of the whole thing as well, the job creation along the value chain. You can create jobs. So we clean up the environment, we clean up the oceans. These days, people go to do fishing and then they catch plastics.
Yeah.
rather than catching fish.
Yeah.
If you have a policy in place and then said that the fuel that is produced, we can easily utilize it in generating part of the thermal energy blend, I think that will go a long way to assist us so that we can also continue to improve upon whatever we do.
Right. We've got just a few minutes more to wrap
Okay.
this up. But what are some of the major challenges that you faced with this?
Thank you very much.
Yeah. You can
When we
briefly take
started,
us through that.
yeah, when we started this work, that was in 2014. Actually, this is a side work, and Mr. Brentford will tell you that there is a bigger project that can clear all the plastic waste in Ghana, and that can cause industrialization from our iron making. That one, maybe that could be another time for this one.
Yeah, we'll get another time
Yeah,
for
that is a bigger one. But when we started this project, I mentioned that we wanted to avoid importation. So we wanted to get everything from Ghana.
Done everything done here.
Yeah. Previously, you are doing pyrolysis, so certainly you need to heat up your systems from temperatures ranging from about 350 degrees Celsius to about up to about 900 degrees Celsius. How do you generate that kind of energy? Currently, as we speak, part of the fuel that is produced is also burned to pyrolyze the process.
Yeah.
We started off by, when we initially started, we were using LPG gas and then we mentioned that no, that will make the process extremely expensive.
Yeah.
So we saw, through our research, we saw that we could use palm kernel shells. Driving across the country, you may find several places where palm kernel shells are not utilized for anything. In Takwa, we had places where palm kernel shells were there. So we started going to them. And we go there, we buy. When I started this project in 2014, a bag of palm kernel shell was sold at 10 Ghana cedis. As you speak, in Takwa, they want to take 200 Ghana cedis.
For a bag of palm kernel.
That will make it even more exorbitant
than just going for the
taking
gas.
for the gas and the like. So that appears to be the major challenge.
Right.
One other thing is also funding, like we mentioned.
Sure.
But of course, we don't want to give up hope yet. We're still working. We believe that you can start small from somewhere.
Yeah.
A garage from UMAT, we can start. That is how we started. And we are moving, we're expanding.
All right. So as we're wrapping this up, what will be your final word on this, Mr. Brainfield? Let me
Sure. So
come to you on that.
Yes, as a business person who is seeking to bridge, bring academia and industry together. That's the beauty. Now the preaching has been that academia and industry should come together. Academia should come together to generate solutions. So this is one of the opportunities when academia develops a solution. From a business perspective, I'm always looking forward to a business partner coming on board with investment to scale these projects up and then sustain them. So my invitation to corporate Ghana, especially those who are playing in the energy sector, petroleum, petrochemical, banks can even come on board. Green environment advocates are all invited to come to the University of Mines and Technology, witness what our great professor is doing, and then bring us some funding to scale this up, because it has a national potential of cutting down our costs a lot and then creating jobs.
The environment,
yes, the
creating
environment.
jobs and cutting down on plastic waste and all that.
Because if we even decide to start locally, that is from Takwa alone, can imagine how we can clear these kind of wastes. And it's not only the pure water you see. Sometimes those white this thing that are behind TVs when you buy new fridge and things, all those things are being used.
Is this styrofoam also?
Yes.
Yeah.
So it's a call that I constantly make to corporate Ghana, energy sector players, banks, green energy revolutionaries to come on board and support us to scale up this project.
All right. Thank you very much, Prof. Your final word, Prof.
it's
I know
interesting.
that there's a lot on your mind.
Yeah.
But you just
Yeah, for now,
summarize it for
we,
me
we
in-
just
in a
want
minute
to
or so.
say that we have the technologies in Ghana to solve all our problems.
Right.
The only thing I would say is that of a policy change. We call on industry to have confidence in it. The independent power producers, we, VRA, to mention but a few,
ECG,
we are telling them ECG,
GMPC,
GMPC,
Ghana
that
gas.
we can produce fuel from non-conventional sources. Even vehicle types, we use them in generating this fuel. We need a collaboration. Maybe we have not done enough as academia, but thankfully we have people like
Your
Mr.
business
Brentfield over
development,
here.
yes.
So we know where to go now.
And get
They should be ready. We are coming. We need a collaborative effort that can take Ghana to the level that
To
we
the next
all
level.
require.
all right.
Thank you very much.
Thank you also, Prof. Professor James Ransford Dankwa
Yes,
is Associate Professor of Engineering and Solid Waste Management and Processing at the University of Mines and Technology. Thank you very much, Prof. Great work you're doing, and we have to push for the necessary funding to come because this has great potential for the country. And Mr. Michael Bremfi, thank you very much. Business Development Manager at UMAT also. Thank you very much for joining us here in the studio. This will do it for Horizon, and this is interesting. This is something that we don't even need to stop talking about.
Just in case someone wants to reach out to us,
Yes.
at least
Okay.
you can pick this number 020 7567 680.
7567.
Yeah, 020 7567 680.
All right.
That is my personal
the
number
number.
as
Okay.
a business development.
All right.
person.
One last
And
time.
020 7567 680.
All right.
Or send me an email, mbremfi@umat.edu.gh. Bremfi, BREMFI,
Right.
@umat.edu.gh, or any of our touch points, our UMAT website. Once you get there, you can always
Get in
search
touch.
and then
All
get
right.
in touch.
Thank you. Thank you very much. You're still listening to The Morning Star. We'll be right back.